there is a new exciting text-to-speech model, Muyan-TTS. So this particular model is a trainable text-to-speech model designed for podcast applications within a $50,000 budget, which is pre-trained on over 100K hours of podcast audio data, enabling zero short text-to-speech synthesis with high-quality voice generation. This also supports speaker adaptations with dozens of minutes of target speech, making it highly customizable for individual voices. In this video, let's try out Muyan-TTS in a Colab notebook to see if I can clone my voice for a text-to-speech generation. So this particular model has been released on Hugging Face. It's got Apache 2.0 license. It is just 3.61 billion parameters, so it will require up to 6 GB RAM of 6 GB of VRAM to run it. So I am running it on a free T4 instance Colab notebook. Okay, so first we need to install this ffmpeg library. This is already installed. Then you need to clone this GitHub repository muyan-tts.git. You have to do cd. You have to go into the folder muyan-tts and then make build. This will install the model. Basically, this will install the library for Muyan-TTS. Then you need to actually download, a lot of models. I'll come to that. So you need to download this Chinese Hubert base, and all the models which you download should be in a folder called pre-trained models whose structure looks like this. So you need to download Chinese Hubert base. You need to download Muyan-TTS. If you want to use Muyan-TTS SFT, you need to download that. So this is what I'm doing over here. From Hugging Face CLI, I'm downloading this particular model and I'm copying it to the local directory. Okay, into the local directory. So the Chinese Hubert base is downloaded. Then you download your Muyan-TTS. Okay. Then you download your. You can also put this into a single command. You have to download Muyan-TTS SFT as well. And after that, you need to log into Hugging Face, login and provide your access token. Otherwise, this doesn't work when I'm trying the inference because it asks for remote code trust is equal to true. So you log into Hugging Face CLI login and provide your access token. So once you do this, what I've done is that I have uploaded into assets. This was the default file which was available, a default recording, which sounds like this.
Although the campaign was not a complete success, it did provide Napoleon with valuable experience and prestige. Although the campaign was not.
Okay. So I didn't want to use this voice. I wanted to make use of my voice, which is this. Hello, this is Ritesh. Hello, this is Ritesh. So I wanted to try this voice out. So I uploaded the voice over here in recording.wave, and in this, there is this, tts.py, right? So you open that file, and you change asset over here, reference wave path to this particular, recording.wave, which I have uploaded now. So if you want to do it on your voice, do a recording of your voice. Put that recording.wave file over here into assets and put this path over here. That's one change which I have done. And the prompt text I've given what I've told in the audio, and I just run it. Okay. I save this file and I run it. And this was the generated file. Another change which I've done, which I forgot to mention, was that, let me go to this TTS So I gave this particular text which needs to be generated now. So I took this particular tryst with destiny speech from Jawaharlal Nehru. Okay. And I copied this particular text over here. So this text is what I want to convert to speech now, okay, which I have pasted over there, and it has generated the file, and the result will be present inside logs folder over here. Okay, so this is the file which I have downloaded. Okay, and it sounds like this.
This is Ritesh. Long years ago we made a tryst with destiny, and now the time comes when we shall redeem our pledge, not wholly or at the stroke of the midnight hour, when the world sleeps, India will awake to life and freedom. A moment comes, which comes but rarely in history, when we step out.
So this is what it has done, kind of cloning of my voice. Okay, so you can judge whether zero shot cloning is it, close to my original voice, right? Which is like this. Hello, this is Ritesh. To me, at least, it sounds different. Okay, but you can judge how close it is. So this is what when I tried with, what you call my own voice. Okay, now we can also edit it and try with the default voice which was available. So for that, what I'm going to do is that I'm going to copy Claire over here. All right, and I'm going to put this over here. Basically, copy the path. Okay. And the default text which was given, let's go over here. There was this example from which I took that default text. I think this is the default text prompt for that particular voice, basically. So let's copy that as well. And, let's copy it over here. Okay. So now this is kind of saved. Now let's run. So it takes around a minute to generate. Let's wait for the results. Output has been generated. Let's just download the output. Okay. So this is the output.
Long years ago, we made a tryst with destiny, and now the time comes when we shall redeem our pledge, not wholly or in full
This was the original voice.
complete success. It did provide Napoleon with valuable experience and prestige.
So here it's done a good job. So probably this is one of the supported voices over here, Clara.wave. Suppose if we want to do on our own voices, then we need to fine tune this model. So they also provided how to fine tune this model over here. They have provided how you can do training. So they've given this example of LibriSpeech, but if you want to organize your data set, if you want to use your data set, then you need to organize data in the format as shown as data process examples. And then you can use train.sh to train this particular model. So if you look at the architecture of this particular model over here, right? So this is the framework of Muyan-TTS. So left is an LLM that models the parallel corpus of text in blue, basically text and audio tokens. Right is a Sowitz model that decodes the generated audio tokens as well as phonemes, speaker embeddings into the audio waveform. So here is the audio input, which an LLM converts it into text tokens and audio tokens, and then that is given as input to your Sowitz model that decodes the generated audio tokens as well as phonemes and speaker embeddings into the audio waveform. So this is their particular model. They have also released a technical report where you can look into further details of how this model was created. So they are open sourcing these two models, including fine tuning code as well, right? Including training code and everything. They have open sourced it. So what else they take over here? So what they're saying is the architecture builds upon GPT Sowitz, incorporating a pre-trained large language model Llama 3.2 billion as a replacement for the AR model, while independently modeling both the LLM and Sowitz components. So they're talking about the architecture over here. Okay, so first they employ an automatic speech recognition model such as Whisper to transcribe the given output, which is then tokenized using the tokenizer of the LLM. So that is how they create the training audio and text input. Okay. Further details are present in this paper, so you can check out this paper to understand more about how they have created Muyan TTS text to speech model. So this was a short video on Muyan TTS. So they have given the other details over here in terms of performance comparison with synthesis speed with other text to speech models like this. They have not compared with 11 Labs or any of those proprietary models. So this is mostly they have compared it with kind of open source systems. I'm not sure if some of them are proprietary over here. Okay, so I will share the Colab notebook. You can go and try it out, and I'll put all the relevant links in the description of the video. It is good that we have another open source text to speech model. This has primarily been trained for podcast kind of for text to speech for podcast applications. That's what they say over here. Hope this video is useful. See you in another video.